Hey guys, it's Miss Johnson and I'm here to bring you our notes for reviewing factoring. We're going to get into a lot of factoring in chapter 8. And so we're going to take a little time outside of class. This is part of your um, outside of class responsibilities to do a little factoring review. So up the top of your page, factor puzzles. We want to pull out GCFs to see what the missing product on the inside of each factor puzzle may be. So in number 1, the GCF from 12 and 15 that can come out of both parts is 3. That comes out of both. The GCF from 12 and 8 that can come out of both parts is 4. All right, so we now know that 4 times some number, this is the GCF that was taken out, 4 times whatever this GCF is gave us 8. Well, we know that 4 times 2 is 8, so that means this factor has to be 2. That factor also has to be 2. And with the 15, 3 times some number gave us 15. Well, we know that that's 5. So this number is 5. That means that number is 5. And the missing product that goes in that hole is 10. 5 times 2. Let's try to get a number 2. So from 8 and 14, I can take out a GCF of 2. That's what gets divided out of that one. From 14 and 21, I can take out a GCF of 7. And we can also check too. 7 times 2 does give me 14, so I know that I'm kind of on the right track there. That means that 7 times some number gave me 21. That number happens to be 3. So then I also know that 2 times some number gave me 8. That number happens to be 4. And then the missing product that's on the inside is 3 times 4, which is 12. Number 3, GCF from 8 and 12 is 4. Remember to look for the greatest common factor, not just any old common factor, because you can also take a 2 out of 8 and 12, but you want the greatest one, which is 4. Then GCF of 12 and 15 is 3. And you can check 3 times 4 does give you the 12 that's inside, so you know you're on the right track. Then ask yourself, 3 times what number gives you 15? Well, that number has to be 5, so then there's a 5 over here. And 4 times what number gives you 8? Well, that number has to be 2, and that means there's a 2 down here. Missing product on the inside, 5 times 2 is 10. Now, take notice of 1 and 3. Numbers 1 and 3 end up being the same factors, just in different orders. And that's just a testament to the fact that you can multiply in any order. Multiplication is commutative, and we can do that in any order. Let's take a look at number 4. Number 4, 15 and 35, they have a GCF of 5. I can take 5 out of both of those. 15 and 18, they have a GCF of 3. And you can check, 5 times 3 does give you 15, so you know you're on the right track there. Then look for the other factors that you need. 3 times what gives you 18? That happens to be 6. So that means there's a 6 here. 5 times what gives you 35? That happens to be 7. So that means there's a 7 down here. So then 7 times 6, 42 is my missing product. And let's take a look at number 5. Number 5, 32 and 40, GCF is 8. 40 and 45, GCF is 5. 5 times 9 gives me 45. 8 times 4 gives me 32. So that means this is a 9, this is a 4. 9 times 4 is 36. And one more of these. 24 and 42 have a GCF of 6. 42 and 35 have a GCF of 7. 6 times 4 gives me 24. That means that's a 4. 7 times 5 gives me 35. That means that's a 5. And putting those two together for the missing product, we get 20. So that's just a little factor puzzle review that talks about pulling apart factors. So just exploring factors. When we multiply, we get a product. So like, for example, 5 times 10 gives us 50. Same with distributing. 5x squared times 3x is 15x to the third. And then 5x squared times 2 is 10x squared. So that's our product. Area also happens to be a product because it's length times width. The area here would be 5 times 8, which is 40, whatever the units are, units squared. Area of the rectangle here, again, is a product, length times width. And the length times the width here would give me 6x to the third units squared. Same thing when we have a binomial times a binomial, then we could go into FOILing, first outside, inside, last. So when I FOIL these, x times x is x squared, x times 2 is 2x, inside would be 3x, and the last terms are 6, and I get x squared plus 5, oops, sorry, there's supposed to be an x there, 5x plus 6 when I FOIL that out. Now, here's the thing about factoring. Factoring is undoing that multiplication, taking apart a number or expression and writing it as a product of its factors. In other words, undoing multiplication, or the opposite of FOILing. That's what's happening when we factor things out. So for example, 20 is 2 times 2 times 5. These are the factors of 20. And 15a to the second b to the third is the same as 3 times 5 times a times a times b times b times b. These are its factors. So that's what we're going to be working on today or reviewing. There's 4 different types of factoring. One is factoring out the GCF, one is factoring by grouping, one is factoring trinomials with a 1 in front, one is factoring general trinomials with a number that's not 1 in front. We're going to take a look at those 4 different types. So let's start with GCF. Pulling out the GCF, GCF stands for greatest common factor. So we just want to look for what's the greatest common factor between all terms in the expression. Well, from 12x and 36, I can take out a 12. That means 12 is my GCF. So if I pull out the GCF out front, 12x divided by 12 is just x, 36 divided by 12 is just 3, and that is my factored form. From number 8, 8x squared and 16x, I can divide by an 8 and an x here because I've got a factor of 8 and a factor of x from both. So I've got an 8x out front, and then 8x squared divided by 8x is just x left over. 16x divided by 8x is just 2 left over. Again, that's my factored form. 39x squared and 13x, still have a factor of x, and now I also have a factor of 13. So I can take out a 13x from both. When I divide 13x out, that's my GCF out front, and what's left over behind that is a 3x plus a 1. I have to write that 1 there, otherwise my whole term would get lost. So 13x divided by 13x is 1. That's what I leave there. Now the last one, number 10, I would take out a 5. I've got a factor of 5 and 5, 20, and 40. I also have 2 factors of x, so x squared, that I can take out of all of those. So I've got a 5x squared out front, and then behind, 5 divided by 5 is 1. X to the 7th divided by x squared is x to the 5th. You had 7 x's, you took 2 of them away. That leaves you with 5 left over. Then in the middle, 20 divided by 5 is 4. X to the third over x squared is x. And the last term, 40 divided by 5 is 8, and x squared over x squared goes away. So that is my factored form of that expression. Then we get into factoring by grouping. Now grouping is similar to taking out the GCF, it's just that we have to take out the GCF twice. And that factoring by grouping then takes us into general trinomials. And when we look at general trinomials with a 1 in front, our life of factoring is actually pretty easy. So I like to set up a factor x here. On the top of my factor x, I take the product of a times c, which in this case is just 8. And the bottom is the b term, which is just 6. Now you want a product of 8 and a sum of 6. So think of 2 numbers that give you a product of 8 and a sum of 6. That would be 4 and 2. So what happens here is you end up with 2 factors because there is a 1 in front of these. Because there's a 1 in front of your x squared. Then you can write your factors out as x plus 4 and x plus 2. Since there's a 1 in front. When there's not a 1 in front, we have to do a little bit more to the factoring. But since there's a 1 in front, that makes our life pretty easy. So 1 in front means I want a product of 12 and a sum of 13. Well, that has to be 12 and 1. 12 times 1 is 12, 12 plus 1 is 13. So again, since there's a 1 in front, x plus 12, x plus 1. Then the last one, again, there's a 1 in front here, so I can set up my factor x. This time it's a product of -4 and a sum of +3. That means I want the two factors 4 and -1. 4 times -1 is -4, 4 minus 1 is 3. So my two factors are x plus 4 and x minus 1. When we get into the sum and difference pattern, when we've got just two factors set up, if you've got a number squared minus another number squared, you end up with this sum and difference pattern where it's the square root of both, where one is subtracted and one is added. Okay, but it's also easy to see if you still set up that factor x. If I look at 14, this is the same thing as x squared plus 0x minus 4. That 0x term has been dropped out because we know writing 0x or adding 0x doesn't make a difference. So I can actually set up my factor x as -4 and 0 on the bottom. So what gives you a product of -4 and a sum of 0? That happens to be 2 and -2. So I end up with x plus 2 and x minus 2 here for my two factors. Same thing in 15. 15 is actually x squared plus 0x minus 64. And so I can set up my factor x. -64 is the product I'm looking for, and 0 is the sum. Well, we all know that we can plug in -8 and +8, and we end up with factors x minus 8 and x plus 8 for our factored form. And notice that those are the same two factors. One is subtracted, one is added, and that's what we have up here. Same two factors, one subtracted, one added. I'm going to leave number 16 for you to do on your own, and we'll move on to the next one. Now, when there's a number in front, here's some steps that you can take note of if you don't remember how to do this, but I'll do a couple out with you, and we'll see how it goes. In 17, the first thing I have to do is multiply the 2 and the 5. 2 times 5 is 10. The middle term stays the same, goes on the bottom. So I need two numbers that multiply to 10, add to 11, that's 10 and 1. Then, how this is different when your number is a 2 instead of a 1 is I have some more factoring to do. I've got to get rid of that 11x and put 10x and 1x in its spot. So that gives me 2x squared plus 10x plus 1x, or just x, plus 5. Then I factor by grouping. This is where factoring by grouping comes back into play. Group the first two, group the last two, and find the GCF. From 2x squared and 10x, I can take out a 2 and an x. And what's left over after I do that is x plus 5. From x and 5, the only GCF I can take out is a 1. And that leaves me with x plus 5. Then, to write out your factored form, the outsides make one factor, 2x plus 1, and the insides make the other, x plus 5. And that is our factored form of the expression. Let's take a look at number 18. In number 18, I need to multiply the 3 times -7. So that's -21. The middle term is -4. So what two numbers give me a product of -21 and a sum of -4? That's -7 and 3. -7 times 3 is -21. -7 plus 3, -4. So get rid of that 4x and put the other ones in its spot. So 3x squared minus 7x plus 3x minus 7. Then I group. Group. It was supposed to be around that 7x. Then take out your GCF. From the first one, I can just take out an x. That's it. There's nothing in common between 3 and 7, so I've got to leave it at that. Then that leaves me with 3x minus 7 behind. From the second group, again, just a 1. Leaves me with 3x minus 7 behind. Factored form, x plus 1, 3x minus 7, and there it is. All right, I'm going to go ahead and stop our video at that point. Please hop back to Schoology and take your quiz, and we will see you all tomorrow.